Two adjacent sides of a parallelogram have equations 3x minus 2y is equal to 1 and x minus 4y is equal to minus 13. One diagonal of the parallelogram has the equation 2x minus 3y equals minus 1. Find the coordinates of the vertices, which means corners, of the parallelogram. Okay, so it would be a good idea to draw this out. So here we have a parallelogram, A, B, C, D. So I've decided to label it A, B, C, D. And we have a line going from B to D. So here we have a diagonal, which is cutting through the parallelogram. And then a line going from A to C, which is another diagonal cutting through the parallelogram. So 3x minus 2y equals 1 is the equation of one of the lines. And the adjacent side is x minus 4y is equal to minus 13. One diagonal of the parallelogram has an equation 2x minus 3y equals minus 1. We want to find the coordinates of the vertices of the parallelogram. So we want to find the coordinates of A, B, C, and D. So we're going to let A be the intersection of the two given sides of the parallelogram, A, B, C, D. 3x minus 2y equals 1, and x minus 4y equals minus 13. So here we have the sides given. So 3x minus 2y equals 1, and x minus 4y equals minus 13. So this is the point where they meet, the intersection. So if we solve these simultaneously, we find that point of intersection. So multiplying equation 1 by minus 2, so 3x by minus 2 is minus 6x, minus 2y by minus 2 is plus 4y, and 1 by minus 2 is minus 2. And then just writing down the second equation, x minus 4y equals minus 13. We can cancel out the 4y and the minus 4y. So we end up with minus 5x equals minus 15. So solving for x, we get x is equal to 3. And then subbing in x is equal to 3 into one of the equations, doesn't matter which one, we get y is equal to 4. So point A, the point of intersection of those two lines, is 3, 4. So now we have one of the vertices, or one of the corners of our parallelogram. Now we need to find B, C, and D. So point B, we can see, is the intersection of the line 3x minus 2y is equal to 1, one of the sides of the parallelogram, and with the diagonal, which is 2x minus 3y is equal to minus 1. So we're going to solve these simultaneously to find point B. So let B be the intersection of the side 3x minus 2y equals 1 and the diagonal 2x minus 3y equals minus 1. So we're going to multiply equation 1 by 3. So 3x times 3 is 9x, minus 2y times 3 is minus 6y, 1 times 3 is 3. And we're going to multiply equation 2 by minus 2. 2x by minus 2 is minus 4x, minus 3y by minus 2 is plus 6y, minus 1 by minus 2 is positive 2. Now we notice that our y's will match up, so they'll cancel. So we're left with 5x equals 5, solving for x, x is equal to 1, and subbing 1 into one of the equations, doesn't matter which one, we get y is equal to 1. So B is 1, 1. So point B, another vertices, or another vertex or corner of our parallelogram, is 1, 1. In a similar way, we can then find D. So we know that this side, AD, is x minus 4y is equal to minus 13. And we know that the diagonal is equal to 2x minus 3y is equal to minus 1. So solving those simultaneously will get us point D. So let D be the intersection of the other side, x minus 4y is equal to minus 13, and the diagonal 2x minus 3y is equal to minus 1. So multiplying equation 1 by minus 2, we get x multiplied by minus 2 is minus 2x, minus 4y multiplied by minus 2 is plus 8y, and minus 13 multiplied by minus 2 is 26. Now our x's will cancel. So we've 8y minus 3y is 5y, 26 minus 1 is 25. So solving for y, we get y is equal to 5, and subbing that into one of the equations, doesn't matter which one, we get x is equal to 7. So the point D is 7, 5. So our other vertex is 7, 5. Now all we have to do is find point C. Now, we're going to work out point C slightly differently, because we were able to find A because we knew this equation and we knew this equation, so we just solved simultaneously. We were able to find B because we knew this equation and we knew this equation, so we could solve simultaneously. And we were able to find D because we knew this equation and this equation, so we could solve simultaneously. However, we do not know the equation for this line, we do not know the equation for this line, and we do not know the equation for the diagonal. So we're not going to use simultaneous equations here. So instead, what we're going to do is get the midpoint of BD. So we know the equation of BD, the diagonal, it was given to us in the question, 2x minus 3y is equal to minus 1. So we want to get the midpoint of BD. So we know 2 points on BD already. We know B and we know D. We already worked that out. So we're going to use the midpoint formula to find the midpoint of the orange line, which is the equation we already know, but it also happens to be the midpoint of AC. So they share this common point. So let M be the midpoint of BD. So we worked out B to be 1, 1, that point B there, that corner, that vertex. We worked out D to be 7, 5, that corner, that vertex. We labelled them x1, y1, x2, y2. And then we sub into our midpoint formula. So we get 1 plus 7 over 2, comma 1 plus 5 over 2, which gives us 4, 3. So the midpoint of the line BD is 4, 3, but it also happens to be the midpoint of AC. So now we have a point on the line AC. Now it's very important that we know that this point M in the middle, so 4, 3, it's very important that we know that this is the midpoint of AC, because we're now going to use translations. We want to know, how did we get from A to M? So point A, we worked out earlier on, was 3, 4. And point M, we worked out just now, is 4, 3. So how do we get from A to M? Well, to get from 3 to 4, we add 1. And to get from 4 to 3, we minus 1. So we now want to do that same translation, the same distance in the same direction. So we've gone from A to M, now we want to go from M to C. So we're going to have to add 1 to the x and subtract 1 to the y. So we're starting off with point M, which is the midpoint, which is 4, 3. We're going to add 1 to the x, so 4 plus 1 is 5. And we're going to subtract 1 to the y, so 3 minus 1 is 2. So this point C ends up being 5, 2.